Hello, my name is Deniz Besiktepe. I'm a PhD candidate in Civil Engineering and Construction Engineering and Management program at Colorado State University. Today, I will present a study of computerized maintenance management system data utilization in facility management that was conducted by myself and professors Mehmet Ozbek and Rebecca Atadero at Colorado State University. As an overview of the presentation, first I will talk about the introduction and purpose, then I will give some details about the background following data collection, methodology, and results. Finally, I will talk about the discussion and conclusions. Building maintenance is defined as any actions carried out to keep the building in an acceptable condition in British Standard 3811. As part of the building maintenance practices and facility management, Computerized Maintenance Management System, commonly known as CMMS, is a software platform that assists in planning and monitoring maintenance activities with real-time data processing. The use of CMMS in manufacturing, production, and also in utility management is widely recognized, especially for maintenance planning and monitoring, condition monitoring, fault detection and diagnostics, and performance improvement. However, in facility management, it is limited and mostly utilized for maintenance scheduling, work order processing, work order tracking in completion time, labor hours, and spare parts. Given that the purpose of the study is to investigate the utilization of CMMS data to identify possible relationships between building characteristics and work orders as the indicators for maintenance issues and equipment failures. Studies conducted in the current literature highlight the following areas related to CMMS. CMMS is more than a data monitoring tool, and it assists in analyzing maintenance information and decision making. Also, challenges revealed in the current literature for the effective use of CMMS in facility management are lack of full understanding its capacity and interoperability, lack of adequate training for the maintenance staff. Also, current research efforts highlight integrating CMMS and building information modeling as well as energy management systems. In addition, emphasis on the use of CMMS data for performance evaluation is highlighted in the current research efforts. In the study, CMMS data is collected from 3 higher education institutions in the state of Colorado between 2013 and 2017. Previous studies revealed the higher frequencies of the electrical, HVAC, and plumbing work orders in CMMS datasets. That's why the datasets were limited to the corrective work orders in these 3 maintenance activities. As a total of 84,524 work orders of 3 higher education institutions were analyzed in the study. The characteristics of the datasets are presented in a table following the total number of work orders per higher education institutions, total number of buildings, total gross square footage, and the average age of facilities per higher education institutions. The methodology comprises descriptive, inferential, and relational statistical analysis for investigating any possible relations between the number of work orders and facility age and facility type. The statistical analysis were performed in IBM SPSS Statistics 26 software. The descriptive statistical analysis comprised the determination of the mean and the standard deviation of the work orders in 3 maintenance activity groups among 3 higher education institutions. The data sets were analyzed for the statistical normality, and based on the Shapiro-Wilk test results, it was determined that the data sets are not normally distributed in any of the 3 higher education institutions. After the determination of non-normality, Spearman's correlation coefficient was used to indicate the relationship between the facility age and the number of work orders with the strength and direction of the relationship. In higher education institution number 1, a weak positive correlation was observed with the facility age and the number of electrical, HVAC, and plumbing work orders. In higher education institution number 2, a weak negative correlation was observed with the facility age and the number of HVAC work orders. And no significant correlation was observed in higher education institution number 3, and Strong positive correlation between electrical, HVAC, and plumbing work orders at all three of the higher education institutions was observed. Based on the available data, it was only possible to classify the facility types in higher education institution number 1. The distribution of the electrical, HVAC, and plumbing work orders was investigated among the facility types in higher education institution number 1, and the null hypothesis of the Kraskov-Wallis test was the distribution of work orders is the same across the categories of the facility type. The Kraskov-Wallis test results provide the decision to reject the null hypothesis among the facility types, and the number of work orders is significantly different across facility types for each maintenance activity type. In the following slides, we can see these significant differences in research, office, library, classroom, and athletic facility types that they received higher number of work orders in the three maintenance activity groups following electrical, HVAC, and plumbing work orders per facility type in higher education institution number 1. The purpose of the study was to investigate the possible utilization of CMMS data to identify any relationships between building characteristics and work orders as the indicators of maintenance issues and equipment failures. Given that CMMS data has the potential to aid FM professionals for strategic planning and decision making, the strong positive correlations observed between electrical, HVAC, and plumbing work orders would assist facility managers in identifying the risks and effects of the possible failures in these three systems. Certain types of facilities such as research, office, library, classroom, and athletic received higher numbers of work orders in the three maintenance activities considered. Improvement areas identified in the data sets are the use of equipment ID or a barcode system, and track of work completion dates might increase the use of data sets for condition assessment in building maintenance and facility management. Future research might include investigating the correlation between the total gross square footage of facilities or the average maintenance cost per square footage with the number of work orders. Finally, integration of CMMS with other technological advancements such as building information modeling, building automation systems, and integrated workplace management systems is important in terms of identifying the future research areas. Thank you very much for your attention to our study and presentation. If you have any questions, please feel free to contact at denizbk@colostate.edu.